Hey guys, today we're going to be verifying identities. This is the last section in chapter 5 for trig. So this is going to feel like unit 1 when we were going over that process of like substituting out equivalent trig values. And today we're just going to be using our formula sheet, and that's why I have it up over here. So the first one, it looks really complicated. We have cosine of 2x divided by sine squared of x, and that's equal to cosecant squared of x minus 2. And just like before, we want to take the left side, transform it into the right side. So if I look at this one, this cosine of 2x over sine squared x, you're better off looking for the new forms because this we recognize as one of our double angle identities. So over here, I got a few options. Notice there's 3 different options for the cosine squared of a. So I'm going to substitute out, for this one, I'm going to try the very first one here. This cosine squared, and I'm just going to use x, sine squared x, and then I'm going to keep the denominator the same. And now, see what happens is we have a cosine squared divided by sine squared, and then we also will have a sine squared. Ooh, I did this one wrong. Never mind. As you can see, that one's not going to work out because we're going to end up with cosine over sine, and then sine divided by sine is 1. So that's not going to get us to the cosecant part. So instead, if you get stuck like what I did, we're going to go to a different one. So let's try, instead of that one, let's do this bottom one here. 1 minus 2 sine of sine squared x. And now this one, when we separate this out, we end up with 1 over sine x minus 2 sine x over sine x. And this is the one that we're looking for because we're going to end up with the sine squareds going away. Forgot my squared there. And then this is the reciprocal. So this ends up being cosecant squared. And then we still have this 2 left. And there we go. We just proved that one. So sometimes it's a little bit of trial and error. If one formula doesn't work out when you're substituting it, try a different one. The next one we're going to do is cosine of x plus sine x times cosine x minus sine x. Now you might recognize this from back in your algebra days, but this is similar to the process if we had like x plus 2 times x minus 2. This one we don't necessarily have to do any sort of substitution with our formula sheet. We're just going to distribute. So just like you did back in the day with the binomials. So this becomes cosine squared x minus sine x cosine x when I distribute here. And then I have a positive sine x cosine x. And then lastly, I end up with this minus sine squared. And now notice the middle terms are going to go away because we have a positive sine x cosine x and a negative. So these two are going to get rid of each other, and then we're left with cosine squared x minus sine squared x. And then we look at our formula sheet, we find that it's right here. We know that that's equivalent to cosine of 2a, or in this case, cosine of 2x, and we just proved it. Okay, on to the last part here. So kind of another similar situation with this one. Notice we have parentheses, tangent 2x times 1 minus tangent squared of x equals 2 tangent of x. So with this one, whenever you see something like a 2x or an x divided by 2, one of those double angle or half angles, take a look at the formula, and you're going to notice that over here we have 2 tangent of a divided by 1 minus tangent squared of a. If we substitute that out in this instance, so I'm going to take this value and replace it. 2 tangent a over 1 minus tangent squared, except it's not a, excuse me, 2 tangent x, and then we still have this parenthesis here, 1 minus tangent squared of x, and then we'll just put that over 1, because now you're going to see that we have the same denominator and numerator here, so we can cross those out, and we do end with just a single 2 tangent of x. So although some of these might look complicated, they do end pretty quickly. That one only had one step in between, and we were able to prove it. All right, this last one, a few more steps to it, but nothing too crazy. Again, all we're going to do here is recognize that we have a squared term. So whenever you're squaring a quantity like this, separate it into 2 parentheses. So sine of x plus cosine of x times sine of x plus cosine of x. And then we can distribute just like we did in that earlier one. So we get sine squared plus sine x cosine x plus sine x cosine x. I'm actually going to stop split screening for just a second here. Plus, and then the last one will be cosine squared. All right, now we have to recognize, well, how do I turn this into a 1 plus sine of 2x? We do have some like terms. These middle terms are going to combine since they're the same thing. And then what I'm going to do is I'm going to move the sine squared and the cosine squared together. So if I put sine squared of x plus cosine squared of x, and then I actually add these two terms here, I get 2 sine x cosine x. And then we just have to remember something from that we previously learned about identities. This is the most important one. This is the Pythagorean identity. And sine squared x plus cosine squared x becomes 1. So then what we can do after this is we still have this 2 sine of x times cosine of x. But we've also seen that before. Now if I pull up my formula sheet, plus 2 sine, we see that one right here. That is the same as sine of 2a. And I kind of had a hint as to that because if we look up here, we're trying to get to sine of 2x. So then the final answer is 1 plus sine 2x. And that's what we were trying to prove. All right, and that's our last example. Definitely try the ones in the workbook. The biggest process is just to start out by looking at it, identifying the pieces that you know, and seeing if there's anything you can substitute out. If not, try to do a little manipulation, like whether that's distributing, multiplying. You never know what you might find, and then it can kind of give you a shortcut to that. But that's it for this one.